Good morning, this is your Stats Sensei, Mr. Spensei, and this is an exit ticket on the inverse norm. So it says for the following scenarios, draw the graph, give the calculator commands, and answer the questions, being certain to box your answers. Um, the fuel efficiency miles per gallon of one car model is normally distributed. Okay, that's important so that we know we can do this. A vehicle has a fuel efficiency in the top 2.5%. What is the associated Z score? Whenever they give us an area percent or probability, so if they give you an area percent or probability, you're going to go to inverse norm. So that's how I know I'm going to inverse norm. It told me it was normal, and then I said, oh, area percent or probability tells me I'm doing here. The next thing I say, oh, they gave me a percent. So I put an X every single time. I just write an X down. All right. The 2.5%. Oh, that's on the top. So that means it's above it. All right. That's important. That means I'm shading from the right to the left. So my drawing is going to look like this. And I know that this area is 0.025. Remember, we can always take percents and divide them by 100. That's where that 0.025 came from. So I'm looking for this area right there. All right. Or I have that area right there. And because I have that area, I know I'm going to inverse norm. All Z scores. Well, that's good. This is a Z score. All Z scores have a mean equal to 0 and a standard deviation equal to 1 because it's a Z score. All right. Because it's a Z, all Z scores have that. So here we go. We're going to go second vars, inverse norm, and see what the calculator asks for. And so since we know it's an inverse norm, we're going to go ahead and write that down. INV norm. That's what the calculator told me. INV norm. Inverse norm. Well, the very first thing it asked for was my area. Well, that's a 2.5 divided by 100, which gives me 0.025. All right. And because it's a Z score, it's 0 and 1. 0 and 1. All right. Now this gets a little bit different. This is my probability, my mean, and my standard deviation. So this really can give you PMS, all right? And hopefully that'll help you remember it. Now, look, I shaded on the right-hand side, so I need to make sure that my calculator, because it's fancy, says right. So right needs to be highlighted. If your calculator doesn't do that, then you're going to have to do 1 minus the 0.025. And I'll show you that in just a moment. So I get a z-score of 1.9599. Now remember, z-scores are the number of standard deviations. So they can be greater than 1, or that you can have negative numbers because they're not probabilities. So z equals 1.9599. We'll box that answer. All right. If your calculator does not go left to right, go second vars, inverse norm. Where it asks for the area, you're going to go 1 minus 0.025. And yours is shading, will be shading from the left, even doesn't have a choice. That's what it does. And I get 1.9599. Same answer. All right. Because this is that value. A vehicle fuel efficiency is in the lowest 12%. All right. So they gave me a percent. So I put an X. Oh, that 1200, that 12 is on the low side. So that means it has to be below. That's good. So that tells me what I'm doing. So now I can draw my picture. And my picture is going to look like this. All Z scores. Mean is 0. Standard deviation of 1. And we're looking for this area right here, which happens to be 0.12. All right. So we're going to go inverse norm. And we have 0.12, 0, 1. All Z scores have that. And remember, this is the probability or the percent. This is the mean. This is the standard deviation. So that's our PMS. So second VARS, inverse norm. And we have 0.12, mean is 0, standard deviation of 1. And notice I'm shaded on the left-hand side. We're good to go. And we get negative 1.1749. Well, it makes sense that we would have a negative z-score because we're below the mean. If it's above the mean, like the previous one, positive, below the mean, we'll have a negative. So z equals negative 1.1749. The next one, the most efficient 5% are associated with what z-score? All right, so we're going to put our x. Oh, these are the most efficient. Is more going to be above or below? Well, more will be above. So this means the 5% is up here. All right. So that tells me what I'm doing. Now I'm always going to have to divide these values by 100 if they're giving me percent. So dividing by 100. So I'm drawing my picture. In my picture, all z-scores have a mean of 0. So we know it's 0 here. That's my mean. But we're looking for this upper 5% because it's the most efficient. So the most efficient is up here. All right. So we'll write inverse norm because that's where we're going on the calculator. And we have 0.05. All z-scores have a mean of 0 and a standard deviation of 1. So probability, mean, standard deviation. So z-score equals second VARS, inverse norm, 0.05, mean is 0, standard deviation of 1. Now be careful, we're shading from the right. And we have 1.6448. And it makes sense that we're going to have a positive z-score because we're above the mean. So z equals 1.6448. The least efficient, okay, 20%. So we have an x, or 20. Oh, that's the lower side. Now, don't forget to divide it by 100. So our mean is 0 because all z-scores have a mean equal to 0. Standard deviation of 1. That's true for all z-scores. And our lowest 20% is somewhere down here. So this is 0.20, all right? Because 20 divided by 100 is 0.20. So that's what I'm looking for. So I have an inverse norm. And 0.20, that's my p-value, 0 and 1. Second VARS, inverse norm, 0.2, 0 and 1. All right, we shaded on the left-hand side, so we need to have left highlighted. And because we're below the mean, we're going to have a negative z-score. So z equals a negative 0.8416. %, achieve a value above what z-score? Huh. So once again, we're still asking for a z-score, but x, we put an x, but it says above. So, oh, that means my 85 is up here. And don't forget, we got to divide it by 100. So, got to be careful when we draw this one. This is a little bit trickier. So we have a 0, we have a mean, and it says above, so that means I'm shading from this way, but this is 85%. Well, 50% is halfway, so I got to come more than halfway. I'm going to have to come down here somewhere. So this right here is what I'm looking for. And this area right here happens to be 0.85. Well, that means my z-score is going to be negative because it's below. All right. So let's look at this thing. Inverse norm. We're looking for an area of 0.85. We have a mean of 0, a standard deviation of 1. So there's our PMS, PMS, PMS. And second VARS, inverse norm, 0.85. Mean of 0, standard deviation of 1. Oh, but we shaded from the right. Make sure right's highlighted. And we get negative 1.036. Left off the negative sign. That's important. Okay, and we would expect a negative because we're below zero. And all z-scores have a mean of 0, standard deviation of 1. What are the z-scores associated with the middle 75%? All right, so this one's going to look a little bit different. So we're going to draw a picture. 0. And they're telling us it's the middle. So they're just telling us, oh, this area right here is going to be, has to be 0.75. And they're wanting us to be centered on it, right? So we have this area that we're looking for, and this is my lower, and this is my upper. So we're going to get an inverse norm. We're really not going to change a whole lot. And we're looking 0.75 because remember, always dividing by 100. Mean is 0, standard deviation of 1. So far, it's looking everything the same. So the only thing different is on the calculator, and it's very simple. Second vars, inverse norm, 0.75 is our probability or our area. Our mean is 0, standard deviation. They said, oh, we want it centered. They wanted the middle. So we have a negative 1.15 and a positive 1.15. So I'm going to go ahead and label this as my PMS. And we have a negative 1.1503 all the way to positive 1.1503. And we know we'd have two values because we have a lower and an upper. All right. So let's box that answer. All right. What are the z-scores associated with the middle 94%? Well, it's going to be very much like what we just did. Mean is 0, but we're looking for 94%. So 0.94. This is going to be my lower. This is going to be my upper because we're going to have two values and we're shading out the middle. So inverse norm. Remember, we're always dividing by 100. So 0.94. That's 94 divided by 100. Mean is 0, standard deviation of 1. And the reason, again, that these are 0 and 1, all z-scores have that value. So this is my PMS. Second vars, inverse norm, 0.9401. We need to be centered because I said in the middle. And we have negative 1.880. And it'd be symmetric. It's positive 1.880. Negative 1.8807. Positive 1.8807. There's my lower. There's my upper. Let's box that answer. All right. Juice bottle, a bottling machine is set to fill juice bottles with a mean of 20.5. All right, so that's important. We have a mean equal to 20.5 and a standard deviation of 0.15. What percentage of the bottles will end up with at least 20 ounces of juice? All right, so we want the probability that X is greater than 20. Um, so at probability that X is greater than 20, it's like, oh, if we're looking for an app, if you're looking for an area percent of probability and we're looking for one, you're gonna have to use a norm CDF. So in this case, our mean is 20.5. And they want to know what's the probability that we have 20 or more. So 20 and shading up to positive infinity. Because they're looking for an app, this is going to be a norm CDF. With my lower bound being 20 upper bound positive infinity, mean of 20.5, standard deviation of 0.15. That's what LUMO, lower, upper, mean, standard deviation. Second VARS, normal CDF, 20, 9 raised to the 99th, mean of 20.5, standard deviation of 0.15. And we end up getting excuse me, this is not right. That drawing is wrong. 20 is below here. So this should be 20, needs to be below here. So I need to be over halfway. And since I'm over halfway, I would expect a value greater than 50%, and I do have it. So equals 0.9957. 0.9995. Because we're just going to go ahead and truncate. That's our probability. All right. 10% of the bottles will contain less than what number of ounces? Ooh, they gave us a percent. If they give us a percent, we're doing an inverse norm. So let's make an X. And it says less. Oh, that means the 10% is down here, or the 10 divided by 100. So my drawing is going to look something like this. We know the mean is 20.5. They gave us that this area right here is 10%, right? And we're looking for that. But because they gave us a percent, we're looking for this X right here. Because they gave us a percent, we know we're going to have to do an inverse norm. So an inverse norm. And what does the calculator ask for on inverse norm? Second VARS, inverse norm. It asks for the area. Okay, we just know the area is 10% or 10 over 100. The mean, we actually have an actual mean. They're not asking for a z-score, so we have to use the actual mean. So 20.5, and we have to actually use the actual standard deviation, which is 0.15. So this is my probability, my mean, and this is my standard deviation. So there's our PMS, and we have 0.1, 20.5, and 0.15. And we're shading to the left. And we end up with 20.3. So this value right here, this X value, we expect it to be 20.30 ounces. X equals 20.3077 ounces. Lastly, 80% of the bottles will contain more than what? Well, once again, we put our X, but 80%, it says more, so that means more is above. All right, so that means I need to draw my picture. So we're going to go 20.5. Well, halfway is 50%, so we have to go over half. And this area right here is going to be 0.80. And we're looking for this X value right here. All right. So we're going to do an inverse norm because they gave us a percent. When they give us a percent, we use an inverse norm. So inverse norm. And they told us it was 0.80. That's our 0.80. There we go. That's our area. They also gave us a mean of 20.5 and a standard deviation of 0.15. So there's our PMS. Second VARS, inverse norm, P 0.8, mean 20.5, standard deviation 0.15. Oops, I went to the wrong spot on the calculator. I'm not sure what happened. Second VARS, norm CDF, excuse me, quit. Second VARS. They gave us a percent, so we have to go to inverse norm. Area. Our probability 0.8. Mean, the actual mean was 20.5. Standard deviation, the actual standard deviation was 0.15. And we started shading from the right. So this needs to be a right-hand value. And we end up getting 20.3737. So X equals 20.3737 ounces. All right. Appreciate you watching. Hope to see you on the next one. Thank you.